All right. Hello, everyone. Welcome to another episode of Biochemistry Capstone Videos. My name is Spencer Hall, and about the only real information you need to know about me is that I will hopefully be graduating come May. So today we're going to be discussing how a protein gets inside the ER, or in other words, the endoplasmic reticulum, and also how it can get stuck in the endoplasmic reticulum membrane. So we got a few things we need to know first before we can discuss the details. The protein. You have a nucleus that contains a lot of the information of how our bodies work. And some of this information is sent out in the form of something called messenger RNA. This is a little piece of how our body works, the information for that. And some things called ribosomes are able to stick on and attach, and they read this code. They translate it. And what ends up coming out from these are a sequence of amino acids. Amino acids are the building blocks of proteins. They are usually summed up in letters such as A, T, S, C, V, P, and you can have repeats, so we'll toss in an A and an S again and a C. There's 20 main amino acids. So this here, which I'll in the future just write out as a little squiggly worm thing, these are found along this little squiggle. This is our amino acid chain, or in other words, our protein. And this is what's going to be getting into our endoplasmic reticulum. Next question, what the heck is the ER I keep referring to? And I'm going to use a different color for this. That is found very close to the nucleus. Looks like something like this. This is the best I can draw with my artistic capabilities. And the endoplasmic reticulum has many purposes. Ultimately, if proteins are able to get inside it or inserted into its skin, the outside layer, they can be sent all over the cell for many useful purposes that keep us alive. So, the ER up close technically does not just look like a flat line. Instead, it looks like this. It's called a double phospholipid bilayer. It sounds super fancy, but all in other words it means is just the skin of the ER. And it looks like this. Let me draw it out a little bit. And this continues on for much longer than you have time to watch me, in both directions. It continues on like that. This is just that little section, and it continues on. Now, I did say that this is a double phospholipid bilayer, so you can expect that there be one phospholipid bilayer, two. Just like your skin, it has multiple layers as well. And continues on over here. You'll notice that I am leaving a little gap. This gap is going to be very useful to us in 1 second. So, again, this continues on. In this gap, we have, it's technically a protein, but it's better to think of it just as a tunnel or a shuttle. Again, remember the purpose of our discussion is so that this amino acid chain is somehow able to enter and get into the inside here. So, let's draw this chain up to the top a little bit. It'll be the exact same chain. One last note is that somewhere along this chain, you have specific letters that are they're considered hydrophobic. And hydrophobic just means it doesn't like water. That may sound extremely basic. You might know a lot of your friends who don't like water, but this is an extremely important chemistry point. It differentiates a lot of things, makes a big deal. So if there is a little portion, let's just pick it up here towards the beginning, that's hydrophobic, somewhere along this tunnel as it is trying to enter, through these layers to get inside the ER, it'll get stuck. Right here. This part right here, it gets stuck in there. The rest of this chain, however, is able to go through. So this chain here is now through here. You think, well, can you just let go here? Unfortunately, that's not how it ends. It's still stuck. And the only way to really get rid of that is with some weapon-like protein. It's called signal peptidase, but just consider it the weapon that comes along. See that point? And it's very sharp. And it cuts off the head of our protein. How sad, right? However, you'll note that the rest of this is now left on the inside. It achieved its purpose of entering the endoplasmic reticulum. And to draw it over here so it makes a little more sense, it has made it through the little tunnel here, and now it's floating on the inside. There is one other or alternative possibility. Rather than being able to enter it, it can be stuck in the wall. And rather than being depicted like this, two parts get stuck. The property that makes them get stuck is the hydrophobic regions we discussed earlier. Yet again, we have another hydrophobic region. That part gets stuck here. So rather than having an entire chain that made it through, as you can see here, it doesn't. So let's fix that real quick for the second look. This weapon suddenly no longer plays a part, luckily. Not such a graphic ending. It now looks like this. Right. You'll note that it is stuck in the wall. This would look like over here, let's pick a new spot, something like this. You've now learned how a protein can be placed inside the skin of the endoplasmic reticulum, and also how it can enter the ER. Both of these serve their purposes, which we will be covering in a future episode. Thank you for watching.